Okay, so this video is going to go over the structures of the eye itself. Now, the eye is a hollow sphere that is made of 3 different layers, and a lot of the older textbooks, and I kind of like this terminology, calls the 3 layers tunics. Now, we'll get into what's in the middle later, but we're going to look at the tunics first. So the outermost layer is called the fibrous tunic because it's made of mostly fibrous connective tissue. And there are 2 parts to the fibrous tunic. This opaque, on this model it's a little beigey, but you would call it the white of your eye. This part is called the sclera, and it's actually a type of like dura mater material. And then right at the front of your eye where the light's going to enter, we change from the opaque sclera to this clear cornea. Now this particular model, the top half of the cornea is gone. That's okay. We're just talking about this right here. All right, so that is the cornea. So the sclera and the cornea make up the fibrous tunic, and where they meet, where this circle is right here, is called the corneal limbus. I can kind of run my stick right along the top here, okay? So that is the first layer, the fibrous tunic. So to see the next tunic, though, we have to go inside, and this particular model is good. It lets you kind of take it off in layers like this. So here's the rest of my fibrous tunic, and now I see the next layer down. The first thing you notice is that I see blood vessels. This is called the vascular tunic. Vascular, of course, means having blood vessels. So another name for the vascular tunic is the uvea. Now, the vascular tunic also has a little bit of difference between what's in the back and what's in the front. In the back, everything from here back is called the choroid. That's that dark material primarily, plus the blood vessels. Now, why is it dark? Well, in the eye, we're dealing with light, and we want to have directed light exactly where we want it to go without bouncing. And so we're going to put dark structures around to catch any stray rays of light. Light that we don't want to be part of our image would be absorbed by the dark color, okay? So from here back, this layer, this vascular tunic, is called the choroid. From here forward, we have several other structures that are part of this vascular tunic. So I'm going to kind of lift this out. Now it looks like the eye's looking at you. Now the first structure on the front of the vascular tunic is called the iris. This is the iris region. And you are genetically programmed to lay down different amounts of different pigments over the iris. Now what the iris actually is a set of 2 different kinds of muscles that control this opening. This dark opening here is your pupil. Now you can see one set really clearly. See these little lines that are going towards the center of the pupil? They are part of the dilator pupillae muscle. And when these muscles constrict, what happens is it pulls this hole larger or dilates the pupil. So that's why it's called the dilator pupillae muscle. Then in the center, which is a little harder to see on this model, they didn't really give us a good view of it. There is the constrictor pupillae muscle, and when it contracts, it actually makes the pupil smaller. So this is at the very, very front of this vascular tunic, and there's a little bit of space between this. I'm going to put it back down the way it was. There's a little bit of space here between the iris and the cornea, and we're going to learn this is called the anterior chamber of the anterior cavity, okay? So that's the iris. Let's see what's going on behind the iris. I'm going to lift this out, okay? Now, there it goes. That's our lens. So something that happens behind the iris is this is what it would look like from the inside, like this. I'm going to take out the lens. Now you can see the back of the iris right here. Okay, and there's the back. The lens is here. Now, on this model, it's kind of hard to tell, but this lens is actually suspended kind of in the, I would say mid-air, but there's not air there. There's jello, by these strings that are attached to this dark part here. This dark part here is called the ciliary body, and the strings are called the ciliary zonules or suspensory ligaments. Now, when we are looking in this area, everything in front of the lens all the way out to the cornea is part of a big part called the anterior cavity. So let me go to this model. This is a cutaway version. So the lens would be right here where my stick is, right in this little trough. And so from here all the way out to the cornea would be the anterior cavity. But notice that the iris and the pupil divide this into 2 other little sections. So from the lens to the back of the pupil and iris is called the posterior chamber of the anterior cavity. And then in front of the pupil and iris out to the cornea is the anterior chamber of the anterior cavity. Hopefully that didn't confuse you too much. So the lens would be here. On this model it's missing. This is the ciliary body. These little lines here are the ciliary zonules or suspensory ligaments. And right here is where this end of the vascular tunic, this part of the ciliary body, meets the inner tunic, which is called the neural tunic. And notice it's kind of got a jagged edge on it. This is referred to as the ora serrata. So that is where the vascular tunic and the neural tunic meet on the inside of the eye. Okay, so one of the jobs of this ciliary body, besides holding the lens and controlling it where it's focusing, is it also makes aqueous humor. The entire anterior cavity, so from the lens out to the cornea, this whole thing, both chambers, are filled with a watery fluid called aqueous humor. And it's made here by the ciliary body. It is secreted, here's the ciliary body, the edge of it, we can see it here. It's secreted into the posterior chamber in front of the lens. It fills up and comes through the pupil and fills up the anterior chamber of the anterior cavity, and then it gets drained away. And where it gets drained away, let me turn my phone down here. Do you see this little dot right here? That is one of the drainage holes. And if I look up here on the top, nope, they didn't really label it on the top. But there would be a drainage hole along the corneal limbus, and those holes are called the Canals of Schlemm. So we make this aqueous humor, we fill up both chambers of the anterior cavity, and then we drain it out through this canal. If we don't drain it out, we get intraocular pressure building up behind the cornea, and that is a condition known as glaucoma. Now, that big lens, let me go back to the smaller model here. Now we're looking at it from the back. So here's my ora serrata around the edge. These little lines represent my suspensory ligaments, and here is my lens. So it would be everything under this lens all the way out to the cornea would be the anterior cavity. All right. Now this lens you see is a nice crystal clear protein-based structure. As we get older, this lens might become cloudy inside. And if this lens becomes cloudy, we have a different condition known as a cataract. And they can go in with a laser and burn off some of the cloudy film sometimes off of a cataract lens. Okay, so that's the end of the middle tunic. The choroid is the back part of it, and right where the choroid meets the retina here is the ora serrata. Then we get to the innermost part, and we get to this other thing. This big piece of plastic here represents the vitreous body. So the front of the eye is filled with a watery fluid, aqueous humor. The back of the eye is filled with a jello-like material called vitreous humor or vitreous body. And you can see the lens kind of nestles right in there. And then if we take that out, we can see the innermost layer of the wall of the eye, and that is here represented in peachy pink, and this is called the retina. So this is part of the neural tunic. Now the retina has some special areas on it. It has this area here. This is called the optic disc, also known as your blind spot, where all the axons of the ganglion cells and the blood vessels that are here are going to exit the eye. There's also really close to it this spot right here. So the receptor cells for the neural tunic are rods and cones. Cones are color sensitive and much more have much better visual acuity, and we're going to put a big concentration of cones right here. So this is going to be called the macula, and in the very center of that is an even tinier spot where we have all cones, and that is called the Fovea Centralis. So this is your spot of best vision on your eye, and this is your spot of no vision on your eye, and they're all part of this innermost neural tunic called the retina. If you look at this model, you can kind of get a better idea. So everything that my stick is pointing to now is the posterior cavity of the eye, where the vitreous body would be. And I'm seeing the innermost part here of the retina, the neural tunic. And then back here, I can kind of make out, this is where my macula is and my fovea centralis. And right here is where all of my axons are leaving. So this is my optic disc that's going to lead into my optic nerve. Also on this model, we have over here a diagram of the layers of the cells of the retina. So this black line here represents the pigmented layer. Right here I can see the ends of the rods and cone receptor cells, photoreceptor cells. Those cells are going to talk to this row of cells, which are known as bipolar cells. And then the bipolar cells are going to transmit the signal to this final row here, which are called the ganglion cells. And it's the axons of these ganglion cells that are going to come together, exit through the back of the eye, and become the optic nerve. Okay, so I think we've covered all of the necessary structures and layers of the eye.